Here we are at question 37 at the end of chapter 9. We have ammonium nitrate, solid, decomposing to produce 3 different types of gases. We have 1.25 grams reacting completely to produce these 3 different products, and we're asked to find the mass of each product formed. When you only have one reactant, there's no limiting reactant calculation because, of course, the one reactant will limit the reaction, and this is reacting completely, so there is no ammonium acetate left over at the end. We don't want to start until the reaction is balanced, so that might be the only tricky part to this one. Because oxygen appears in 2 places here, I thought that I would start with hydrogen first. There were 2 on the entirely on the product side, and yet 4 over here. So I put a 2 in front of the H2O, and that 2 is there. That impacted the oxygen, but we'll get to that in a second. 2 nitrogen. And I thought there might have to be a 2 here. You can hear me hesitating, but look, there's already 2 N's in ammonium nitrate. There's an N in the ammonium cation, and there's an M in the nitrate anion. So I'm going to point right to the board instead of in the camera because I'm moving around. So there's already 2 N's and 2 N's over here. I've made that 4 by putting a 2 in front, and so I just have to balance the oxygen now. So with the 2 in front of the water molecule, that would give me 2 oxygens, but I already had 2 over here, so that would give me 4, and I only had 3, so I need 1 less over here. So I thought if I put 1/2 in front of the O2, that would give me 1 added to the 2 over here. Remember, I've put a 2 in front of the water molecule. So that's why there's a 1/2, the 2 I put, and that's why the 1/2 is there. So if I take 1/2 of O2, that's 1 oxygen, plus 2 oxygens gives me the 3 needed over here. And I had 2 nitrogens, 2 nitrogens, 3 oxygen, 3 oxygen, and 2 times 2, 4 H's and 4 H's. The reason why I multiplied the whole equation then after that by 2 is to get rid of the fraction. So if I multiply by that denominator, of course that's going to cancel out, but it has an impact on every other term in the chemical equation, and that's why overall the balanced equation is 2 ammonium acetate goes to 2 N2 plus O2, because a 1/2 times 2 is 1, plus 4 H2O, because that 2 times the 2 gives me 4. So now I have a balanced equation to work with, and now it is very straightforward. I'm starting with 1.25 grams of ammonium acetate. The first thing I do is convert that mass to moles. The molar mass is 80.043. And so I'm converting a mass of ammonium nitrate to moles of ammonium nitrate, and then in the next step, and I'm just continuing the calculation, you can see that moles of ammonium nitrate will go out with moles of ammonium nitrate, so and being converted to moles of N2. And I'm using that why is it 2 moles of N2 over 2 moles of ammonium nitrate? Look at your balanced equation. What that conversion factor is telling you is that 2 moles of N2 form for every 2 moles of ammonium nitrate consumed. So those 2's come out of the coefficients of the equation. And moving along in that calculation, I see that I would now have converted my value to moles of nitrogen. And in the last step, I convert to a mass of nitrogen using the molar mass, not of N, but of N2, which is why it's 28.02 and not 14.01. In the next line, I got lazy because, again, I'm starting with the mass, 1.25 grams of NH4NO3. I can hear you. I actually hear you asking me, what if we did that on the exam? Would you take marks off? Not if you got the right answer, no. 1.25 grams of ammonium nitrate times, be neat, one just like this, times the 1 over the molar mass, that converts it to moles. And away we go now. Instead of nitrogen, it's oxygen. So I'm converting moles of ammonium nitrate to moles of O2 produced. And the 1 mole of O2 over the 2 moles of ammonium nitrate, again, where does that come from? It comes from the balanced equation, because I can see 1 mole of O2 is produced every time 2 moles of ammonium nitrate are consumed. And the final entry in that line is to convert moles of O2 to mass of O2. Again, at O2, so it's not 15.9994, but rather twice that amount, and you get a mass of O2. And finally, 1.25 grams ditto of ammonium nitrate convert to moles of ammonium nitrate, and now converted to moles of water. The 4 moles of water over the 2 moles of ammonium nitrate, you know where it comes from. There's a 4 in the balanced equation as a stoichiometric coefficient, and there's a 2 in front of the ammonium nitrate. So quite literally, it's telling me that 4 moles of water form for every 2 moles of ammonium nitrate consumed. And finally, convert that to a mass. So that's how we do it. And in theory, those should all add up, because it's a single reactant, to a 1.25. And that looks about right, because look, 0.4, 0.5 is 9, and 2 more, and then the residuals, and that's 1.25. So that's done correctly.